This video is for section 9.5. We're going to look at theorem 9.7. This theorem says if a segment joins the midpoints of two sides of a triangle, then it is parallel to the third side, and its measure equals 1/2 the measure of the third side. That might sound confusing, but here's what it means. If you have a triangle inside of a triangle, like we have here, and these points are midpoints, they can tell you they're midpoints, or they can show you by saying that this segment and this segment are congruent by those marks. Also, this segment and this segment need to be congruent by those marks. Notice how we use different marks. So this length doesn't have to be the same as that for that to be a midpoint. So that's a midpoint, that's a midpoint. This segment is called a midsegment. So if you have a midsegment of a triangle, here's what you know about it. That midsegment must be parallel to that other side of the triangle. Also, this midsegment is going to be half the length of that. So if this has a length of 5, then this has a length of 10. If this has a length of 50, then this has a length of 100. Okay. Now, these being parallel, remember from previous sections, tells you that these two triangles are similar. So we know lots of things with these being parallel. Here's an example. Points X, Y, and Z are midpoints of the sides of this big triangle UVW. So if X is a midpoint, we know that. If Y is a midpoint, we know that. If Z is a midpoint, we know this. Here's some other things we know. Each of these segments is then a midsegment. And if they're midsegments, then they're parallel to the side that they don't touch. Also, they're half the length. So if we just look at this segment right here and we say that this is 5, that would make this 10. And if this is 10, then each of these pieces is 5, which is what this is. So this midsegment has the same length as each of these. And you can do this with each of these midsegments. So you end up with this information. So we have this big triangle that has these 4 little triangles inside of it. And if you notice, these 4 little triangles are congruent to each other by side, side, side. So something that you know down here is going to match up with something here, here, and here, so on and so forth. So this is what number 4 says. V to W is 6A. So here's V, here's W. This is 6A. How long is it from X to Y? It's going to be half of that. So it'll be 3A. Half of 6A is 3A. If X to Z is 7C, how far is it from U to W? It'd be 14C. Number 6, the measure of angle WZY. Let's make sure we know where that is. WZY. I'm just going to put an arc on it so we know. That's this angle. If that's 2B plus 1, what's the measure of angle WVU? Here's W, here's V, here's U. They're talking about this angle right here. What do we know about these angle measures? Well, let's look at the little triangles. See how this angle is in between a side with 1 mark and 3 marks? This one is 2. And these are congruent triangles. So that means these are congruent angles. So if this one is 2B plus 1, this one is 2. 2B plus 1. Number 7, X to Z. That's a segment, and it's parallel to another segment. There's a couple different answers here, because this segment is parallel to this segment UW, or you can say it's parallel to the pieces of it as well. Number 8, y to z. That has a length of c. How far is it from u to v? If this is c, this would be twice as big. It would be 2c. Here's another example. We have a triangle inside a triangle. These are parallel. Notice how this is not marked as a midsegment necessarily. We need to figure out what x is. Well, notice how this segment is an entire side of the little triangle, and this segment is an entire side of the big triangle. This is an entire side of the small triangle, and this guy is not the entire side length of the big triangle. So we need one of these concepts. You need to know how far it is from A to C. All you do is add this together with this. X minus 2 plus x plus 4. That gives you 2x, because we're just adding the x's. And then you have a positive 4 plus a negative 2. So this whole side is 2x plus 2. So we're going to use this proportion, 6 to 9. That's our scale factor for the triangles. That's going to equal this entire side of the small triangle, x plus 4, compared with the whole thing, 2x plus 2. We need to cross multiply. So we're going to take 6 times the quantity 2x plus 2. What in the world was that? I think my mouse is going goofy. That's a 2. 9 times the quantity x plus 4. We're going to distribute. So we're going to get 12x plus 12, and that's going to equal 9x plus 36. We're going to subtract 9x from both sides. We're going to subtract 12 from both sides. We're going to divide by 3. X is equal to 8. And if you know that, you can figure out how far it is from B to C, because if this is 8, 8 plus 4 is obviously 12. A to C is the whole thing. 2 times 8, 16, plus 2 would be 18. You can check your work. We know that 6/9 is 2/3. Well, what's 12 to 18? 12 to 18 is also 2/3. 6 goes into both. We know that's the answer.